Hey guys, this is I know a little bit different, but I wanted to make a video and help you guys out with the two-way tables, Venn diagrams, and probability exercise that I had you do on Khan Academy. Noticed a lot of your scores. Based on a lot of your scores, it really looked like we were struggling a little bit. So I thought I'd make this video to kind of open up a window into my brain and kind of how I work through this. And maybe if you don't have a process or you're struggling, maybe this gives you some insight on how you can do it. Um, Helps you out, gives you a process, and maybe eliminates some of the misconceptions you're having. As always, if I don't answer your question or you want help with a different Khan Academy assignment, you can feel free to email me and I can do one of these for that one. All right, so two-way tables, Venn diagrams, and probability. This first problem, we see a two-way table here. It says the principal of a high school needs to plan seating for commencement. Following two-way table displays data for students who are involved in the commencement. So I notice here on the left, we've got our grade level for juniors and seniors. And then we've got, also we're breaking them down in choir or not in choir. Okay. So what's our question? For these students, are the events senior and not in choir mutually exclusive? So let's back up a second. What does mutually exclusive mean? Well, another word for that is disjoint. That can be helpful to remember because we think, the joints in your body are what kind of unify stuff in my very limited understanding of biology. Or anatomy, I should say. So if you think joint as in your joints join stuff together, then disjoint you can think not together. Another example you've heard me use, mutually exclusive. If you talk to your parents or maybe an older sibling, the phrase exclusive used to mean with dating. So an example, my wife and I are exclusive. We don't go see other people. Otherwise, we wouldn't be married. In other words, the events us being married um, and seeing other people cannot happen at the same time because we are exclusive. Only one of those things can happen. I can't be married and then go see someone else. Obviously, that would not work. But it used to be that if a dating couple, was not exclusive, then technically it was okay for them to, I guess, go see other people. Not recommending that, but funny, weird way, but that's how I always remember it. My wife and I are exclusive. So me being married and seeing someone else cannot happen at the same time. So mutually exclusive, we think not together, can't happen at the same time. Whereas not mutually exclusive would be, yeah, that's cool. They can happen at the same time. So when I see senior and not in choir as mutually exclusive, I'm thinking, can those not happen at the same time? Well, no, that's not the case. We see, in fact, that there are 436 seniors that are not in choir. So clearly, these are not mutually exclusive. So I'm going to go with no. Now we're told to find the probability that a randomly selected student is a senior or not in choir. With or, we think add. So we're going to be adding together these things. Now, but I got to be careful because they're not mutually exclusive. What do I mean by that? Well, or we think add, so you go, okay, well, I'll just add the number of seniors and add those not in choir, and we're good to go, right? Well, if we do that, and I'm going to go ahead and do that, I would get a grand total of 898 students that are not in choir or seniors. Well, wait a minute. Our grand total of students is only 480. That doesn't make sense. And it's because when they're not mutually exclusive, you don't just add together the number of seniors and the number not in choir, but you have to take away the number that are in both because they get double counted when we just add them together. So what I'm going to do is I'm going to take my number of seniors, 459. I'm going to, yes, add it to the number, not in choir, but then I'm going to minus it by those who are in both categories. Okay, so my calculator screen kind of looks like this, adding together the 459 and the 439, but minusing the 436. And I find that there are 462 students that would be considered a senior or not in choir. Now, I'm not going to type in 462 here. Why? Because it's looking for P of, and what that means is we want the probability. Well, probability is part over whole. So I'm going to take that 462 and I'm going to divide it by 480. And when I do that, I get 0.9625. Okay. And So I'm going to type in here 0.9625. Okay, that would be the probability. And we got that one correct. Okay, 0.9625 is the probability. Okay, so let's move on to our next one. A restaurant noted what type of food its customers purchased last week. Here are the results. 15%. Okay, ooh, this is a little tricky. All right, so noted what type of food its customers purchased last week. Here are the results. So here's what I see. If you add up all these probabilities, 15, 55, 10, and 20, you'll notice we get 100%. So we got to be careful on how we read this. One, I'm going to look at this 20%. The 20% is kind of out in the white area by itself. That's going to be the group of people that didn't buy either burgers nor fries. They got something else off the menu. 10% ordered only fries. 15% ordered only a burger. And then remember, the shaded region for Venn diagrams means, hey, we ordered both. So 55% ordered a burger and fries. Okay. So first things first, in the sample, are the events burger and fries mutually exclusive? Automatically, I'm going to go, no, they're not. Remember, mutually exclusive, we think can't happen at the same time. Obviously, that's not the case because 55% of our customers ordered a burger and fries. So they are not mutually exclusive. I'm going to go with no. Now we want to know burger or fries. Hopefully you see the similarity to the last problem. Be careful here. You cannot just add up the probability that they ordered a burger or they ordered fries. You can't quite add both of those up. Okay. So what we're going to do is the probability they bought a burger plus the probability they bought fries minus the probability they bought both. So what's that going to look like? Well, let's just look at the burger category for a second here. Well, 15% of people bought a burger. 55% bought a burger and fries. Okay. What does that mean? Well, that means in grand total, if I do 15 plus 55, that means 70% of people got some form of burger. 15% getting a burger, 55% getting a burger and fries. So 70% of people got a burger. 70% of people got some form of burger, whether it was just a burger or a burger and fries. So we got 70% here. Now we look at the fry category, and again, we see 10% only ordered fries, but 55% got fries with a burger. So if I add 10 and 55, I get 65. So 65% of people who came in got fries. Now, naturally, you would go, okay, Mr. Carter, here, I'll show you my calculator screen. These are what we've done so far. You go, okay, well, 70 plus 65. Hey, I know or means add. So if 70% of people got a burger and 65% got fries, so I just add those up. But again, alarm bells hopefully going off. That's 135%. Well, wait a minute. We can't get 135%. That would mean over the total amount of people that came in bought. That doesn't make sense. And it's because, again, this is not mutually exclusive. So we have to subtract the probability that they got both. Because what we did is we double counted the 55%. We threw the 55% in with the burgers and in with the fries. Now, what we just need to do to rectify that is we do our 70 plus our 65, right? 70% of people got burgers, 65% got fries. We just need to take away 55 because that is the amount of people that got double counted. And we find that 80% of people, once we take away that 55, 80% of people ordered a burger or fries. Another way of thinking about that is the whole shaded region, whether you look at the both or just the burger or the fries, you look at all those, look at how many people weren't in that category, right? We said right off the bat, 20% of people weren't shaded, which means they did not order a burger or fries. Well, if 20% of people didn't get a burger or fries, that means 80% of people did. Okay, it's kind of that all the probabilities got in the sample space got to add to 100. 20% didn't get a burger or fries. That means 80% of people did. Again, further confirmation that it should be 80%, and it is. Okay. Let me see if I can do a couple more. Let me go back maybe. Let's go back here. Give me 1 second. Sorry, I X'd out of it. Okay. We got a couple more problems here that we can work through. A civics teacher asked her students to indicate whether they believed each of the two headlines. One headline was false and the other was true, but students did not know this. The probability that a student selected at random believed the true headline was 90%. They believed the false headline was 82%. 75% believed both. In this sample, are the events believe the false and believe the true mutually exclusive? We talked about this before. I'm not going to spend a lot of time on this. Answer is no. Mutually exclusive can't happen at the same time. Clearly, it can because 75% of people believe both the true and the false headline. So what's the probability they believe true or false? Again, we've learned with not mutually exclusive. We know or means add, but when they can happen at the same time, we don't want to double count. So I'm going to take the 90% that believe the true headline plus, because or means plus, the 82% that believed the false. That gives me 172%, which obviously doesn't make sense, but we realize that since 75% believe both, we've double counted. So what the math looks like here, I've added them together and then subtracted the 75 that believe both, and that gave me 97%. Okay, so I'm going to check that. Oh. Okay, I think 97 is the answer. I think I forgot to enter it as a decimal. Yeah, that's the error there. Okay, when you're dealing with probability, we want to enter that in as decimals. Maybe if I typed, I don't know, I'd have to try. Maybe if I type 97%, that would work. I don't know, but 0.97. So there's kind of the error there. We'll do one more of these. Hospital track the day of the week. Got another contingency table here. We've got scheduled versus unscheduled up top. We've got the day of birth on the left. Are Tuesday and Friday mutually exclusive? So finally, we get a little bit different one. Here we're comparing Tuesday and Friday. It is not possible for a baby to be born on Tuesday and on Friday, not the same baby. So these are mutually exclusive. So the nice thing when they're mutually exclusive is we can just add them together and not worry about double counting because they can't occur at the same time. So I add together the probability that they were born on a Tuesday versus a Friday. So what's the chance of babies born on a Tuesday? Well, 90 babies were born on Tuesday. We see that 70 were born on Friday. I get 160 babies in total between Tuesday and Friday. So 160 were born on Tuesday or Friday. We divide that by our total of 500, because that's how many total babies we're looking at here. And we find that that turns out to be 0.32 or 32%. There's a 32% chance or a 0.32 chance a baby was born on Tuesday or Friday. Guys, I hope this helps. Let me know if you have further questions.